kitchen and welcome to my mathematics class. As usual, today I have taken topic evaluation of limits of algebraic function part 2. Here I have written part 2 because I'm teaching evaluation of limits in different parts. I'm taking different type of question part wise. Alright. So evaluate the following limits. I have taken today question based on this theorem as we have proved already. Limit of x raised to power n as minus a raised to power n upon x minus a as x tends to a is equal to n a n minus 1. Today all these questions I have taken on the based of this theorem. So today I'll teach how to use this theorem to evaluate the limits of function. Okay. First we try to understand. I have proved also you have to know before applying the limit of this means function. I mean to this theorem. How to use before applying you need to see x a and here also x a, right, x a. Suppose very simple. I'll take here if you have a limit, right? Let's suppose limit here, let's suppose David, right? Here here also we need David raised to power n minus, here also we need David minus you can take here Rita, let's suppose Rita raised to power n, here also we need Rita. Here also as changed to David, as changed to David, as David changed to Rita. See here, if here is David, here is David, here is David. David representing x and Rita representing it. Then we can write down according to this theorem we can write down n times Rita raised to power n minus 1. This is the theorem. Okay? So before applying you need to see these things. Otherwise if your theorem is not in this, means question in this form, then you can't use this theorem. Okay? I think clearly understood. Okay. Here we go in questions. So I'm taking first question. Solution of first question, limit of x raised to power 4 16 upon x minus 2 as x tends to 2 is equal to C. So again let me write down limit of x raised to power n raised to power n x minus a as x tends to a is equal to n a raised to power n minus 1. This is the theorem. We have to apply this theorem to evaluate this function. First, let's bring this form in this form, right? Okay, so this function in this form, limit x raised to power 4 minus, we can write down 2 raised to power 4 and same, alright, and x2 here also x2. Okay, so already we have in denominator x minus 2. So I think you understood. So this function, this whole scenario is in this form. So it says, and without any hesitation, we can apply this. Okay, it's gonna be 4 times 2. Instead of a we have 2. Instead of 4 n we have here 4. All right, and here 4 minus 1. And 4 times 2 raised to power 3, as you know 2 raised to power 3 is 8, is equal to 32. 32 is the limit of this function. So easy, so fantastic, wonderful result we got, right? And very easily we got, there is no any problem. So I think you got how to find out how do we evaluate the limit of this type of function. Okay, so all right, here is another type of, again, little bit twist as compared to the first one question. Okay, second question, solution. Question second, here limit of x raised to power 15 minus 1 upon x raised to power 10 minus 1 as x tends to 1. So here is one problem. If you go through this theorem, you will find here x minus a. According to that, we need here x minus 1 in denominator, or okay, here also we need again numerator. Denominator should be divided by x minus 1, numerator also should be divided by x minus, then we will get in this form. Alright, so okay, although x1, 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 everything is all one. Here is 1, 1. Okay, so limit, we can write down like this way, x raised to power 15 minus 1 upon, and x raised to power 10 minus 1, we can write down x minus 1 upon x minus 1. Any question? Okay, as we can multiply up and down, as you know. So if you think, okay, here x is 1, exactly x is not 1, since x tends to 1 implies x minus 1 is not equal to 0. X approaches 1. That's why we can multiply up and down by x minus 1. Okay. Now we can, okay, so I'm writing here limit of x raised to power 15 minus 1 upon x minus 1 into x minus 1 upon x raised to power 10 minus 1. Alright, all you know this arrangement, and the next line we have limit as x tends to 1 of function x raised to power 15 minus 1 upon x minus 1 whole upon, also we can write down x raised to power 10 minus 1 upon, one more line for your simplicity, for the sake of simplicity, and 15 minus 1 upon x minus 1 into 1 upon 10 minus 1, we can write down like this way. Simple algebra is equal to limit as x tends to 1 of x tends to 15 minus 1 upon x minus 1 whole upon, means this whole thing is divided by x raised to power 10 minus 1 upon x minus 1. Clear everybody? And here no need to use bracket. So alright, so first question clear. I'm going to expand it, erasing. Okay, so my lines here after this, as we have studied in algebra of limits, if you recall that algebra of limits, we can write down like this way also, a limit of limit as x tends to 1 of x raised to power 50 minus 1 upon x minus 1, a limit of x raised to power 10 minus 1 upon x minus 1 as x tends to 1. Okay, so very nice. Here we got this scenario, and here also we got to be the same form. Now we can apply the formula. Okay, is equal to here 1. Okay, one more thing I forgot to write down. Okay, so so at last, okay, we can write down here x raised to power 15, and here also we can write down 1 raised to power 10. As you know, okay, since 1 raised to power 15 is equal to 1, and 1 raised to power 10 is also 1. Okay, so we can write down, okay, instead of 1 raised to power 10, 15, just to make the formula. Okay, alright, so first let's say, okay, in this form, okay, actually exactly it was not, okay, now it is in this form because power was same, and here also and. Okay, now we can apply according to that Here in numerator 15 into 1 raised to power 15 minus 1, and here in denominator 10 into 1 raised to power 10 minus 1. Just be completed here. Mathematics. Okay, here 15. 15. So 1 raised to power 14 means simply 1. We can write on 10 into 1 raised to power 9 means 1. Okay, it's gonna 15 upon 10. So both goes by a same number. So that is our 5. So 5 3s are 15, 5 2s are 10. So this is your limit of this function. I think you understood how to this one in the same way, exactly same. Instead of 15, instead of 10, we have here 1 upon 3 fraction. It doesn't matter. And here 1 upon 6. So you can handle it, right? So that's why uh, I'm planning to leave you for practice. So alright, practice this question. Practice, okay, yourself. So mathematics means, okay, as I told you already, practice, 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 then definitely you're gonna be genius in mathematics, and you will love definitely the mathematics. Okay, next one. Let's see the next question. Let's see here. Little bit twist. I'm starting from here. Solution 1/4. Okay. Limit of 8x raised to power 3 minus 1 out of 16 raised to power 4 minus 1 as x tends to 1 upon 2, right? So let's try to bring 1 upon 2 here, 8 common, x raised to power 3 minus 1 upon 8, and 16 common, 4 here, 1 upon 16. Okay, clear? And 8 upon 16 mean limit as x tends to 1 by 2, here 1 upon 2, and here we have x3, 1 upon 8 means 1 upon 2 raised to power 3 upon here x raised to power 4 minus 1 upon 2 raised to power 4. Here 1 upon 2 we can write down outside, as I told you already in some standard results on limit, and x cube minus 1 upon 2 whole cube. Here x raised to 4 1 by 2 raised to power 4. Now wonderful. As I here just let's recap. And raised to power n x minus a is equal to n a n minus 1. Right? So see, okay, almost okay. We got to get this one, this portion here in denominator also we got to get same portion, but we need okay x here also divided by x minus same question. Now 1 upon 2 limit x tends to 1 by 2 here x cube. Now 1 upon 2 3 here x raised to 4 minus 1 upon 2 raised to power 4. It can x minus 1 upon 2 x minus 1 upon 2, right? Since your x tends to 1 upon 2 implies x minus 1 upon 2 is not equal to 0. That's why we can multiply. Don't think we are multiplying up and down by 0 upon 0. Okay. So after this here is equal to 1 by 2 limit of here I'm writing now directly x raised to power 3 minus 1 upon 2 raised to power 3 upon x minus 1 upon 2 and x raised to power 4 minus 1 upon 2 and this double upon x minus 1 upon 2. This is the numerator, this is the denominator now. 1 upon 2, we can write down limit, here I forgot 1 by 2, as x tends to 1 by 2, here lack of x3, 1 by 2, 3, x minus 1 by 2, limit, as x tends to 1 by 2, here x raised to power 4 minus 1 by 2 raised to power 4 upon x minus 1 upon 2. Now is equal to 1 by 2. We can in numerator 1 3 times 1 upon 2, 3 minus 1, and in denominator 4 times 1 upon 2 raised to power 4 minus 1. So now I think you can simplify, right? It's easy and simple arithmetic. Now you can simplify. All right. So I think you're clear. Here, okay, just I will give you the hint, okay, how to find out the solution of this question. Right? Just hint, okay. I'm not going to solve all. If you get okay hint, I think you can crack down this question. Okay. Now I'm erasing here this part. This question done, and this also done. This done. Now here hint for this. Limit of x raised to power 3 plus 27 upon x raised to power 5 plus 243 as x tends to minus 3. Okay, here don't get confused. We can, it's easy. Minus 3, here also we need minus 3. X raised to power 3 plus minus 3 raised to power 3. X raised to power 5 plus minus 3 raised to power 5. So I think you can arrange, okay, remaining portion, right? As you know, okay, minus 3 raised to power 3 minus 27. Okay, mistake here. So alright, minus 27. Okay, I have done a mistake here. Minus 3 raised to power 5 is equal to also minus 243. Alright? Minus 243 here, see. Minus 27, minus 3 into minus 3 into minus 3 into minus 3. 1, 2, 3, 4, and minus 5. 1, 2, 3, 27, 27, 81, and minus 3 again, okay, times you will get it here, minus 243. Alright, sometimes okay, I may do calculation mistakes, so I'm ensuring myself, is it clear or not? Okay. But here is, we have plus sign, okay, this is alright. Now here we can't use okay plus because it's gonna be negative. It's gonna be negative. So if you use here negative, now it will become positive 27, alright. And now here, if you use here negative, then positive plus 243 will get, okay. Alright. So now I think you can use, okay, just you need, okay, x minus 3, x minus 3. So okay, so directly now I'm writing, I think you got enough idea. X3 minus 3 raised to power 3, we need here x minus 3. You can write down like this, but don't write a plus. X raised to power 5 because we need, okay, same, right? X raised to power 5 minus 3 raised to power 5 upon x raised to power minus 3. So after this, thereafter you can handle, okay, very easily. You will not have any problem, right? If you have problem, you can write down in comment box. I will definitely, okay, give you the response of that question. Clear here, okay, 6th number. This is also a little bit, okay, different type of. Here is 1 plus, till now we got x. Here we have inside the bracket 1 plus x, okay, 2 terms, okay. So let's see how to. Okay, in simple way, here limit as x tends to 0, 1 plus x raised to power 5 minus 1 upon x. So we need okay this form. If we have it in this form, then only we can write down. Okay, let's try limit 1 plus x raised to power 5 minus 1 here, no problem. 1 raised to power 5 is 1 upon 1 plus x minus 1. Can we write down like this way? Oh yes, surely, because 1 minus 1 get cancelled. Or here x, so x. Okay. Here also you need to write down x 1 plus x tends to 1. Now see, 1 plus x 1. Okay. Now in this form we have, can we write down this one? See, if x tends to 0, implies x plus 1 also tends to 1, right? That's why we can write down. Now, so simple in this form, this already in this form, we can write down 1 5 into 1 raised to power 5 minus 1. So 5 into 1 is equal to 5. 5 is the limit of function. We have another way also, just putting x is equal to 1 plus h, right? By putting also we can do, putting 1 plus x is equal to h, right? Or x is equal to 1 plus h. This way also we can do. Alright, so if you can arrange, you can do like this, right? Okay? Alright, so I think you got enough ideas. Now I'll give you the questions for practice, so that you can do more and more practice, and you will be able to crack down this type of question based on this theorem. Alright, so now you will see the questions for practice. So I've written questions for practice. Questions for practice. These all questions are based on this theorem. So I have explained. I have solved many questions for you. So I think you will not going to get any problems in solving these questions. You can crack down very easily. All right. So very simple questions are given. If you do practice, you will be definitely benefited, right? You will love the calculus, you will love the limits. So that's my aim. You should love here. Okay, one method this here I have given. Similar type of question. This one, right? These two questions I have given. Same type of questions. Here. This way arrangement, you can do some arrangements here also. Same, you will try another method. So let me here, you can just replace this one if you want to. Just putting 1 plus x is equal to h, and so as your x tends to, you can write down, so h tends to, so when x tends to 0, when x tends to 0, then h tends to 1, right? Putting method. Another method, alternative for this question. If you don't know the arrangement, you can do like this. You can just replace 1 plus x. You can put 1 plus h when x, change the limit. Limit will be also changed. Because this is the here x tends to 0. 0 means for variable x. Now we need h. When 1 plus x is equal to h. When x tends to 0, then h is going to be 1. Tends to 1, going to be tends to 1, right? And so we have limit x tends to 0, 1 plus x raised to power 5 minus 1 upon x is equal to limit, instead of x tends to 0, because we are changing the variable, here it becomes h tends to 1. 1 plus x means h tends to 5 minus 1 x, because here we have used 1 plus x is equal to h, so x becomes your h minus 1. Now directly you can use formula. Alright, now you can use formula. So this is also second method to crack down this type of problem, right? Otherwise, if you know the arrangement, okay, if you can do arrangement, that's the easy, okay, all right. So you can finish within 2 or 3 steps, all right. So once again, let me tell you, okay, just recap, go through each and every question of limits, evaluation of these limits and of algebraic functions, try to find out. So that I hope, okay, you're gonna love to solve these questions, right? Because really all these questions are based on this. All right, if you are new, then definitely, okay, you will get interest. If you are old, okay, it will be refreshed and you will feel, okay, yes, I know this type of question. So watch, keep watching my channel. This is totally mathematics tutorial topics, tutorial channel. Here we will discuss, okay, mostly mathematics topics and limits, each and every part of the limits. I'm going to tell, okay, just part wise we are going to firstly algebraic functions and how many types of, okay, algebraic functions are there to be evaluated, limits, all right. So then we will move into the transcendental functions. Transcendental functions means we'll find out the limit of your you know, right, transcendental, which are not, okay, algebraic, limit of trigonometrical functions, exponential function, logarithmic functions, and so on, all right. So stay with my channel and keep watching. So thank you for watching my video, uh, and subscribe. Don't forget to subscribe, because your subscription is very important. If you subscribe, that will boost me, and I will make for you more and more videos, and newcomer will be definitely benefited, okay, from these videos. Okay, thank you, bye bye, have a wonderful time.